everybody. Today we're going to do 10.2, which is comparing data displayed in box plots. So last year we did talk about box and whisker plots a little bit. We didn't get too into them, but we did do them. So what we're going to talk about today is how to analyze them. So let's just refresh what a box plot actually shows. They show 5 key values that represent a set of data. It shows us the least and the greatest value. Those are represented by the whiskers. So this is the least value, and then this is the greatest value. All you do is follow it down to see what the numbers are. The lower and the upper quartiles are represented by the ends of your box. So this would be your lower quartile, and this would be your upper quartile. And then finally, the median is shown, and that's the line inside your box. It's not always in the middle of the box, so I'm not going to say that. So if you're actually going to make your own dot plot, you have to arrange the data in order, and then you break it up into 4 equal size parts or quarters, and then you draw the box and whiskers plot. Okay, so the number of points a high school basketball player scored during the games he played this season are organized in this box plot shown below. Okay, so first we're going to say what the least and the greatest values are. So you look at the whiskers, the smallest value is 15, and the greatest is 30. Okay, the median, if you follow it down, is right here. That's 21. Describe what it means. Okay, so the median is 21. What it does is it divides the data into 2 halves. Okay, so we have a lower half and an upper half. This would be the lower half. This would be the upper half. So now we're going to talk about the lower and the upper quartiles. So the lower quartile is going to be here. So that's in between 17 and 18. So that's 17 and a half. And then the upper quartile is in between 27 and 28. So that's 27 and a half. Okay. So the lower quartile, and if you remember from last year, we called it Q1, is 17 and a half. And if you don't remember this, I would write it down. It is the median of the lower half of the data. And then the upper quartile is the median of the upper half. Oops, sorry about that. And the upper quartile, remember, is Q3, 27 and a half. And of course, I'll just write it out for you. It's the median of the upper half. Okay? So if we were to look at the first half of the data, the lower half, and we found the median of all those values, it would be 17 and a half. And then the upper half of the data, if we found the median of it, it would be 27 and a half. The interquartile range is also known as the IQR. And again, we actually did talk about this in 6th grade, but it's probably so far away that we forgot it. To find the interquartile range, you just take the upper quartile and the lower quartile and subtract them. So you just basically the end of your box and the beginning of your box and subtract them. So you just do Q3 minus Q1, so 27 and a half minus 17 and a half. So the interquartile range is 10 points. And I'm saying points because this was points scored. Sorry. Okay. So let's talk about how we can compare 2 box plots numerically according to their centers or medians and their spreads, which we are also calling variability. Range and interquartile range are both measures of spread. Box plots with similar variability should have similar boxes and whiskers. So remember that when we talked about variability for the first time, we're talking about how much the values are changing, how much they're spread out. So if the data values are spread out similarly, then their boxes and their whiskers should look pretty similar. Okay, so example 1 is an example of this. So this one's solved for us, so we're just going to talk through it and look at it, and then we'll do our own. So this box plot shows the distribution of times spent shopping by 2 different groups. Okay, so group A, you can compare everything about it, but group A spent this amount of time shopping, group B spent this amount of time shopping. So let's look. If we compare the shapes, the position and the lengths of the boxes and whiskers appear to be very similar, so it's true. The length is almost the same, and the whiskers are very, very similar as well. But in both of the examples, the right whisker is much shorter than the left. Okay. If we're going to compare the centers, so the center is 40 for group B, and for group A, it's a little bit more than 45. So they're telling us it's 47.5. I don't know how we could get that from there, but anyway, so it just means that group A's median was a little bit longer than group B. So group A spent a little bit longer shopping. Comparing the spreads, you can do the interquartile range. So for group A, that would be 55 minus 30, which would be 25. And then group B is right before 60, so we could say 59 minus, they're approximating 32, which is about 27 minutes. Super, super similar. Okay, and that's really it. So you're just comparing but using actual values. So let's do the your turn, and we'll do this one together. Okay, so we're going to compare these two. They have similar variability because we can see that everything's pretty much close. So we're going to compare the shapes, centers, and spreads. So this is football player weights in 2 different groups. Okay, so the shape, they have similar shapes. But group B has a shorter box and shorter whiskers. Okay, now let's talk about the median. Okay, group A median is here, group B median is here, so group B has a larger median, so we can say that. Group B's median is greater than group A. Okay, and then the fact that group B's box is shorter tells us that the variability is less, right? The range is less. So most of the data is closer together in group B. So group A has more variability. Okay, so you can say that however you'd like. The weights are more spread out in group A. The data is closer together in group B. There's a lot of ways to say it. Okay, I'm going to say that there's less variability in group B. The data is closer together. I'll put it in parentheses. Okay, and the other way, the formal way that we would do that would be to calculate the interquartile range, of course, right? So it would be, but we can't see this exact value. It's a little bit less than 310, and then this is a little bit less than 210. Okay, so that's probably about 100 for going from 200 and let's say it's 7 up to 307. So also. Okay, and this one's just a little bit more. Okay, and that's it. Okay, so now let's talk about box plots with different variability and how we can compare those. Okay, so these ones look very different. They're usually in different locations. So in this case, first example, we're looking at the distribution of the number of team wristbands sold daily by 2 different stores over the same time period. So this one's done for us, so we're going to take a look at the shape of the box plots. So store A, the box and the whiskers are both much longer than store B, right? the centers, store A's median is less than store B, right? So store A's median, if you're going to look at it, it's in between 40 and 45, maybe 43. Store B is about 51. So store A's median is close to store B's minimum value, which is kind of crazy. 50% of store A's daily sales were less than the sales on store B's worst day. So their worst day, they only sold 40 something, right? But half of their values are less than that. So store B on average does a lot better than store A. Then to compare the spreads, we can see store A definitely has a greater spread. The range and the interquartile range are both greater. So the range goes all the way up to 70, probably 6, down to about 25. And the interquartile range is also greater. So the smaller the boxes, the smaller the whiskers, the less your data is varying, okay? So store A has a greater spread. 4 of store B's key values are greater than store A's corresponding values. So overall, they had more sales. But you can see the lower quartile is higher, the median is higher, the upper quartile, and the greatest value. The only thing that is not higher was the lowest value. Okay, so all of this stuff shows that store B altogether, store B did better with their sales. Okay, so let's finish this up by doing our own example here. I think I got this from the guided practice, I think. Let me just make sure I didn't skip over something. Okay. Yeah, so this is from the guided practice. We're looking at hockey players and volleyball players' height. Okay, so first you're going to say which group has the greater median, then which has the shortest player, and which has an interquartile range of about 10. So why don't we pause, give it a shot, and then check your answers. Okay, this one was pretty easy. So the greater median height is the volleyball players. So you can see that their median height is about 74 inches versus the hockey players who have a median height of about 70 inches. The shortest players belong to the hockey player group. As you can see, the smallest value is here, which is around 64 inches. And then the last question, hopefully you didn't rush and just go with the first one you found, but both of the groups have an interquartile range of about 10. So you can see we have 76 minus 66, which is 10, but also the volleyball players are around 78 minus 68, which is also 10. So they both have an interquartile range of about 10. Okay, guys, so that's it for today. I know box plots can be somewhat tricky, so just do your best, and you'll be fine. Have fun.